Okay, again, good morning, class. This is the solution for the problem I gave you last time. This is not yet your problem set, okay, so I'll still be changing this. Um, okay, so the first thing we have to take note is to locate the plastic centroid. Have you located the plastic centroid? Ito ba yung nakuha niyo? YP?
Yes po sir, same po.
Okay, so good, no? So I will not discuss
Apo.
this anymore because this is easy to locate. So your XP is not, walang problema kasi symmetrical siya dito sa vertical axis. Okay? So this is symmetrical in this vertical axis here. Maybe we can try to convert this first to PDF para masulatan ko siya. Okay? So just wait for a moment please. Okay, so this is example problem. Uh, Balance. Okay, so this is an example problem on the balance parameters. You call the PB, MB, and EB balance parameters, okay? Because they are computed on the basis of the balance condition. So I cannot convert the file. Okay, so it's already converted. So maybe we can place it on my whiteboard here so that I'll be able to explain to you better. Okay. Okay. Okay, so this is now my, let's see. Okay, can you see now my screen here, class?
Opo sir.
Yes, sir.
Okay, so let's start. I will no longer solve YP. Is that okay with you? Or do you have some confusion still on this part? Huh? Okay na to, ano?
Okay lang po, sir.
Okay, so I'll move to the balance parameters. So in order for you to be able to solve it quite accurately, class, you have to tabulate all the given values here, just like what I did in my Excel file. Okay, so I tabulated the values. Okay, you can see my value on the screen tabulated on the basis of the given condition. Okay, so from FC prime, Fy, so these are the values. Of course, the units are must be consistent. Okay, these are in megapascal, millimeter, millimeter square, millimeter, etc. Okay, Okay, so let's go to the table. So in the table of computation, you will notice that mas marami yung laman, no? Kesa dun sa table ng plastic centroid, no? So the table of computation for the plastic centroid is far less than the content of the table for the computation of the balance parameter. Why? Because we added up, magdadagdag tayo ng dalawang column actually, yung distance. So this refers to the distance from okay. So I'm talking now of this table here. So this refers to the distance from always from the compression fiber, the extreme compression fiber, up to the centroid of the element or the component. Okay, so up to the centroid, the CG of the element, or whether it's a concrete element or a steel element, you just get that. So these are the distances. Yung area, madali lang kunin ito, okay? On the balance parameter, this area here is not the area of the whole section, no? So the area here is actually the area of the concrete block, okay? The compression block. And the area of the compression block, if you will notice, if we have here a triangular section, if this is the neutral axis, your area is simply this part here. Okay, it's a triangle. Okay, so what is this depth here? This is beta 1 times C balance. Okay, this is or simply this is your A balance. Beta 1 times C balance multiplied by whatever is the base here. Ano ba yung base natin dito? Okay, so the base can be taken by simple ratio and proportion. Okay, so if this is x, we can take the proportion of the small triangle and the big triangle here. So if we know beta 1 CB, we can compute for x. Okay, so x is over A balance is equal to the height, which is 260 over, I think this is 300. So you get x there. So the area of this now is simply 1/2 of beta 1 CB times x, which is the ratio 260 over 300 times A balance, which is beta 1 CB. So yun yung ilalagay nyo dito. Okay? So the computation is quite involved. So remember that you have a concrete component here. Because this is already a cracked concrete, you don't consider this part here below. Okay, is that understood, class?
Yes, sir.
Okay, so for the steel area, no problem. You just write down all the areas there. So steel 1 is the first steel from the compression side. Okay, so you always have to start on the compression side. Where's the compression side? The compression side is from the top. Okay, so if you look at the figure, you start from the top. This is 490, 490, and 3 times 490. Okay, so those are the area. For the distances, again, this is the distance from the compression fiber. You just get the centroid of this triangle at the compression fiber. This is the topmost fiber that is in compression, no? So this is your 81.60, and it is 2/3 what? 2/3 of beta 1 C balance. Okay? Of course, the steel, no problem because these are given. 100, 155, and 210 can be easily computed by means of the distances here. Okay, this is 100, and then 260 minus 105 is 155, and 110 plus 100 is 210. Okay, so those are the distances enumerated on the steel components. Okay, now here comes the catch, no? Here comes the trick. We have 3 stresses because we have to finally get the correct stress. Okay, for the concrete, there's no problem. The stresses are just the same, 0.85 FC prime. Okay, but for the steel, we have to assume, we have to compute for the calculated stress on the basis of the formula Fs is equal to 600 C minus D 1 or Di's all over C, where the Di's are the D of the steel layer, D1, D2, D3. Okay, so yung mga Di's mo dito, ito yung D1, D2, D3, etc. Kung 10 yan, 10 layer, 10 yun. Okay, so this is the computed stress. You compute this here. And this is the maximum stress. You compare it with Fy. In the comparison, it must be absolute comparison, no? Is this greater than Fy? No. So use 183. Is this greater than Fy? No. Use 45.83 negative. Is this greater than Fy? No. So you use 275. Okay, you carry the sign. If this is positive, it means it is in compression. If it is negative, it means it is in tension. So you don't have to worry about the direction of your force because the sign will give you the direction. Okay? So this is just a comparison of the computed stress or calculated stress with the maximum given value of Fy. This is the correction considering the displaced concrete. So we take note that we have a negative 0.85 F per C prime as a correction factor, but this is only applicable for compression. For tension, because the concrete cracks, there is no displaced concrete. So there's no correction on these two because these are in tension. No correction, no correction. This has a correction. 183 minus 17 is 166. Okay, and then you simply multiply corrected stress with the area, you get the force. Okay, so how about the moment? Okay, so the table was cut. I'll show you now the Excel. You have a moment arm here, which is equivalent to YP minus the distances here. What is YP? YP was computed 84.877. So you simply get 84 minus the distance 81. Why is it? 93. Okay, let's double check it. 84. Okay, so sorry class, this 84 is based on the bottom. Am I right? Sino yung nag-compute sa inyo kanina? Yung ating
Yes po,
discuss
sir.
na YP class is measured from the bottom, no? So this is the one that is 80 something. Okay, the YP that I'm going to use in my computation for the moment arm must be from the compression side. So I have to subtract 260 minus the actual YP there. Okay, but for intent and purpose of the discussion, we can call this our true YP, no? So this can also be YP from the top, this is YP from the bottom. So in our case here, in my lecture, I'm referring to the formula YP is from the, okay, from the top. So YP is 260 minus 84.87 minus 81, you get this one. Okay, so these are now the values for your YP. Okay, we have here 93, 75, 20, and negative 34.8. Okay, so knowing that, we simply compute for the moment. So we have the arm times the force is equal to the moment. So this is simply the force times the moment arm. Okay, so you just add, compute, multiply, and then sum. This is your MB. Okay, for your PV, so you just take the sum of this, you get your PV. And if I divide MB and PV, I get EB. Okay, so roughly your answer for EB will be 93.924. Okay, so that computes your value for the balance parameter using a tabulated solution done in Excel. Okay, so it's very difficult to do it using the equations, but it can be it is manageable, but I think you will find it hard to accurately assume the direction of your forces, especially when your steel layers are very many, no? So it can exceed even 4 layers. Some columns have 10 layers, and so on and so forth. Okay, so if there are any questions, you can address your concerns afterwards, and I end my video lecture at this point. Okay, thank you for listening.